Hello, everyone, and welcome to our podcast. My name is Kate, and I'm a product engineer at Pilot. I work with journeys, and this is a customer-facing product.
Hi, everyone. My name is José. I work at the Tauro team at Pilot. I'm a product engineer working mainly on pricing-related topics.
And today we're going to be discussing a clean code. Very exciting topic for me, actually.
It's one of our favorite topics to discuss.
Welcome to the podcast for product engineers.
Yeah, so José, tell me, why do you think that clean code matters?
So I think the first thing that we need to mention about this is that there are many measures by which we can measure the quality of a digital product. One of them could be performance, the other could be defect rates, but there's this invisible measure, which is code quality, which is not usually apparent to the end user, but for us as engineers, it has very high importance. And I think that we want to dissect why that is, and we really want to understand and get to the bottom of this topic. And so I would like to ask you maybe, why do you think code quality is important, both for engineering teams, and how does it create business value?
I would say that basically messy code isn't just frustrating for developers, it's also very costly, right? Because when you wanted to create a new feature, for example, for me as a developer, as if I want to create a new feature and if the code is super messy and super unclean and ununderstandable, it takes time to develop something new. And when there are no tests, when variables are named poorly, it takes so much time and it's so frustrating. So, José, as we both know that clean code matters, right? So it matters for so many different reasons. First of all, it's very costly. It slows down development. It increases bugs. It creates team bottlenecks, right? Like every time when you create something new, you want to work with something that is understandable, that is clean. But what would you say is the biggest issue with clean code for you as for developer?
So for me, really, it is about development speed and about iteration speed. So if you have a code base that is very cumbersome, where you have a lot of tangled code, where you have very low test coverage, this is really going to impact the speed at which you can move. So if we need to implement a new feature in our platform, having a strong test coverage, for example, is going to enable us to make changes confidently while being certain that we're not breaking existing features. Or if we want to change the way something is done, if we want to refactor it, having a strong code base to begin with and having good test coverage is always going to be helpful here.
Okay, so we discussed why it matters, why the clean code matters, but what kind of metrics would you use to track if the code is clean or not? How can we define it?
I think that's actually a very interesting question, because I think we could see code quality as a highly subjective subject. But there are, in fact, metrics that we can use to track whether you're performing well in terms of code quality. So, of course, defect rates and incident count is something that we use to evaluate how well we're doing. It's frankly something that we've been improving a lot on. And the job that we made in the last couple of years, refactoring everything related to journeys and making sure that we have code quality as a top goal, I think has been very important in that sense. In terms of other metrics, of course, you can have customer satisfaction with your product. So if you have a higher code quality code base, of course, you're going to have fewer bugs, less crashes, hopefully a more performant application. And this can be measured in customer satisfaction in the end.
Exactly, and bug reopen rates, right? Mm-hmm. When we have so many similar bug tickets, it definitely says something about our code, right? So I think it's very important. But okay, so we can start creating a new code, or we can refactor the old one, right? Mm-hmm. So let's talk about new code. What would be your recommendation when you create a new code? What would be the best practices to follow when you create a new code?
Mm-hmm. So I think definitely, as a team, you should discuss and decide on what are the values that you have in terms of code quality, and that there should be a strong alignment on every part in the direction that you want to follow. Because these products we're working on, they're not being built by a single engineer. And so it's not just one person's opinion and decisions that matter here. Really having consensus and ensuring that everyone is on the same page is very important. Then I would always suggest that you start with a strong base with linting and type checking. So especially if you're working with JavaScript, of course, you should always have TypeScript. You should always have some sort of linting framework like ESLint. And this is going to ensure that, at least through static analysis, that best practices are followed and that the way data flows in your application is seamless and that there are no points where things are breaking because the data you're working with has an unexpected shape.
Yeah, for sure. I also like asking myself several questions when I create a new code. For example, like, is this code readable at a glance? Mm-hmm. So, like, if any other person can really understand, because the code is not for machine, right? It's for us, for other developers. Or like, is this abstraction helping or hiding? I think it's also very important to understand, like, what does this abstraction do? Or, for example, am I naming things well? So, all of us know this, like one-letter variables, right? Like A, B, C, D, it's not possible to understand what is happening. Or are my tests shaped like my code? I think this is also very important, because if we have tests that do not follow the business logics of our code, it's like they test something clearly wrong here, right? Or what happens if this fails? Like, if this part of my code fails, I think it's also very important. But do you know do you have any clean code patterns which we should avoid? Like, what we should avoid?
So one of my biggest coding pet peeves is seeing very deep levels of abstraction. So imagine you have essentially 10 utility functions that are calling each other in a chain. And here you are really hiding the logic of the operation that's being performed in many different levels of abstraction. And personally, I enjoy working with the fewest levels of abstractions that I can get away with to maintain clarity and the highest code quality possible. Oftentimes, this is, of course, impossible to avoid. So we're working with applications with multiple layers, with the client side and API side, and oftentimes external dependencies. And so, of course, these levels have to exist. But keeping your code base as shallow as possible, while still following other clean coding patterns, I think is optimal.
Yeah, for me, the biggest issue is over-engineering or premature optimization. Basically, those are kind of the same, like two sides of one medal. So when I see the function which was created to work on something which will be developed in the future, but it was never there, oh my God, it's so annoying. Or, for example, when I see the function which has, I don't know, like 50 lines of code, but in the end, when you try to untangle it, it's basically calculate 2 + 2. And it's so annoying. I think all of the functions, what they should do, they should just accept all of the params that they need, and they return only what they need, right?
So keeping your functions as pure as possible, trying to go with immutable patterns over mutable patterns, and always valuing the single responsibility principle as a core principle of your quality standards.
Yeah, exactly. And it's not like we're striving for a perfect code, right? There is no such thing as perfect code. What we want to have is the code that helps our teams move faster. And this is, I think, basically the main storm of every development process. But okay, what would you say when you work with legacy code base? What would be your pattern to follow? Because this is like a tricky one, right? When you create something new, it's easy. You can just greenfield and everything. But when you already have something which is already tangled, what would you do?
So I think the first step you have to follow is untangling what's already there, right? I know this is hard, but oftentimes you'll be able to spot the loose ends. You'll see things that are not being used. You start by removing those, and then you see that oftentimes you have layers of abstraction which are no longer necessary because in the meantime the functionality changed, the stack changed, and these can be reduced into shallower layers. And always doing this with buy-in from the entire team, and especially ensuring that you have a strong code review process to ensure that you're going in the right direction, I think are very important core principles.
Yeah, actually for code review is very interesting because if I remember right, Google has this like specific program for reviewing code. I don't remember actually how it's called. I think it's Google Reliability Program or something. I'm not sure if I remember it correctly. But basically they train their developers to review the code for like at least half a year to make sure that they all follow the same principles of code review. And it gives the code the shape that everyone follows, and that's why they are so fast, right? Because this is the main goal, like to be faster. I think it's really cool. We should definitely do that too.
Also, there's something that you mention often, which is the Boy Scout rule. So if you're working on a legacy code base, you're oftentimes developing new features on top of something that already exists, and you're going to come across something that is not right or that can be improved upon. And I feel that it is our responsibility as engineers to improve what's already there as we go along. I think that we shouldn't take a sprint or a month to refactor existing code and not build new features. I think that if we are refactoring and improving things as we go along, and always leaving it better than it already was, then you're going to strive towards better code quality.
Yeah, exactly. I completely agree with you here. And also, we should refactor for understanding, right? Mm-hmm. Because when you understand what is happening in your code, like if you, for example, someone wakes you up at 2 a.m. and says, what is happening in this line of code? And you're like, I have no idea. Of course you have no idea. Even if it was your code, which was created a year ago, you might still be lost, right? In this unclear abstractions that were used. So yeah, I think it's very, very important to know that. And also, I think I would say that minimizing surface area also, right? I know that you're a big fan of small merge requests, right?
I really am. So the more granular you can make your refactors, I think the better they are to review. And the easier it is to unblock small changes on your applications. So I prefer having 10 merge requests with 100 line changes on each than having one single merge request with 1,000 lines changed, right? Because those become way harder to review. Then if there's one single issue on that 1,000-line merge request, it's going to block the entire refactoring process. And it's also way easier to miss issues when the surface area that you're targeting and that you're changing is very large. So if you just keep it simple, I think this is going to always help you.
Yeah, for sure. I have to say that I always enjoy seeing your 10 merge requests in a row, like with changing 2 or 3 lines of code. I'm like, oh yeah, this is so nice. This is so easy to review, man. Like I really like it. And also I think we should pair. We should pair more on all of the refactorings. Like it shouldn't be work of just one developer on the team. We should work on it as a team because we are the team. We should do it together, and we should involve as much people as we can into this process, not only for other people to know what we're doing, but also for having like a separate pair of eyes on what we're doing, right?
I think this is also really a cultural topic. So if you're working in an engineering team which has this strong culture of collaboration and of pair programming and of strong code review, then you're always going to be better off. I think the quality here will always increase as collaboration increases.
Yeah, I agree. So we touched a bit new code, we touched a bit old code, but also right now, since we are in 2025, right, we're all hyped on AI. What would you say about vibe coding and clean code? Do you have any opinions on that?
So I think by now we're all aware that vibe coding can be a dangerous process, especially with security concerns. That, as you know, LLMs hallucinate. They can make mistakes. They can introduce subtle bugs into your code that you're not aware of. And so even if you're using these AI-assisted coding tools, you should always be mindful that their output is not perfect. And there should be a human in the loop here. So you should always review all of the work that your LLMs or your agents do for you. And it's important that the engineers here are the ones in charge of the decision-making process, and they're not just fully relying on LLMs to make big architectural decisions. Also, I think something that's important to mention here is that AI-assisted coding becomes way better and way stronger when you already follow high code quality principles. And so basically, it's the garbage in, garbage out principle. If your code base is tangled and it's a mess and it doesn't work from a code quality standpoint, the AI is going to be working on top of that, and it's probably going to follow those bad patterns and even introduce larger issues into your code base. And so ensuring that you keep good code quality, high code quality to begin with, is always going to improve your outcomes when it comes to AI-assisted coding.
Yeah, for sure. So basically, we should teach AI through examples, right? If we have an example of a good code base, in this case, it will also follow our patterns, right? And when we have a defined, for example, linters, and when we have defined standards already, the code that our new friend will generate will be much better than if we didn't have those, right? And also, I like, to be honest, use AI for refactoring. So I can give it a function which is very messy, and I can ask it, like, please, first of all, explain me what is happening here. And second of all, give me some examples of how it could be improved. And it gives me so many different ideas, which I wouldn't come up with myself. And it's so nice. It speeds up my work at some point, and it also gives me some ideas of how I can make my code much cleaner, I never follow it directly, of course, because we have to understand what is happening here. But to use it, it's very nice. How often do you use it?
Every day.
Yeah,
I
same.
think it's just a very big part of our job now. I also find that AI-assisted coding tools are very helpful in increasing the test coverage on your application and in essentially thinking of scenarios that you wouldn't have thought of. So, for example, in the past, I've worked on different layers of the application, which had inconsistent test coverage. And just by telling the AI, follow this pattern that is being followed here for this particular utility, but create new tests for this new utility, I find that it's very helpful on that, and it ends up saving you a lot of time. Of course, it's not perfect. It doesn't always produce the best outcome, but it's great to get you started at least with introducing higher test coverage into your application.
Yeah, for sure. Yeah, I completely agree with you here. Exactly as you said, we always have to have a human in the loop. So it makes total sense for us to also review what is happening there. So in the end, I want to say that basically I wanna quote one of the very good writers, so Antoine de Saint-Exupéry. I really like this guy. Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. And I think when we are thinking about the clean code, this is exactly what we should follow. Yeah, we shouldn't add more. We should take away something that is not there, right?
Agreed. For me, it's one of the most pleasurable parts of refactoring code is to actually take out what is not essential. And for me, the best analogy when I'm thinking about code quality is a kitchen. So if you're cooking and you're cleaning as you go, and you keep everything lean, clean, organized, then you're always going to have a better experience as you keep cooking, as opposed to if you're a very messy chef and you're creating a mess in the kitchen and you leave everything dirty and everything unorganized, the next time you're going to cook, you're going to have a harder time, of course. And the quality of the end product is not going to be as good. So I think following these principles, staying organized, is always going to lead to better outcomes.
Yeah, exactly. Basically, as game theory says, we should always collaborate. In this case, we will have a better outcome. Yeah, so thank you so much. It was really nice talking to you, as usual.
Thank you so much, Kate. This was very, very fun.
You've been listening to the podcast for product engineers. Don't forget to subscribe and join us next time.